This is lesson 4 in the Spatial Viz app, and it's 2D to 3D. So being able to go from 2D orthographics into and produce 3D isometrics. So please note that this lecture assumes that you have already done lesson 3, which is orthocubes, and that's where we went from 3D to 2D, and we tried to go from an isometric to orthographic projections. So please make sure that you go back to that lesson if you haven't already looked at it yet. So in this particular module, we're going to go from 2D orthographic views, which are shown on the left-hand side. It's the front view, the top view, and the right side view. And we're going to see if we can produce the 3D isometric. So if you recall, the dimensions of the three principal views, like the top and the front view share width as a dimension. The front and the right side view share height as a dimension, and then the top view and the right side view share depth as a dimension. So those are the dimensions that we see, and because of looking at those objects, we should be able to produce the 3D isometric from these drawings, these principal views. So going back to the glass box approach, it still applies. In this case, how do we produce the 3D image from those orthographic projections, and how do we project them? So again, being able to visualize in 3D from 2D views, what's important about it, again, I mentioned in medicine, when you're trying to do some kind of 2D thing where you're sticking a needle and you're looking at a screen, but you really want to make sure you're not going too far into the blood vessel or into the organ, so you have to be able to visualize in 3D even though you're only looking at 2D. In dentistry, you might have 2D x-rays, but you need to figure out what's going on three-dimensionally. In chemistry, you have 2D molecules, but you really want to know how things are bonding together and what the structure looks like. And so how do we draw 3D objects from 2D views? So going from 2D to 3D, we first take our depth, our height, and our width from the views, and we create what we call a glass box on the right-hand side. So our top view shows that we have a width of 5, and it shows us we have a depth of 4, and then maybe our front view shows us what our height is, and we can create what we call the bounding box, the glass box. And once we do that, then we draw each of the views that we see from each side. So the top view, we draw both of those. We draw what the top view looks like, and it's shaded in blue. We can draw what the front view looks like, and we can draw what the side view looks like. And so from there, then that's on the bounding box. Now we have to kind of cut out things to make sure we get what the final view looks like. And so we know that if we eliminate, because there's a white box, we don't have any shape there. So what we do is we can eliminate that, and we can see that the front view and the top view, they had solid lines across them, indicating there was a change in elevation. And so this is what the appropriate planes look like. So we erase any of the unnecessary lines, like from the bounding box, that are no longer there, and that gives us the final isometric drawing. So you can start off like this, creating the glass box. It's very useful. Eventually, you want to try to do things without having to do the glass box and to mentally do it in yourself. So here's an animation that helps us visualize how to go from 2D to isometric. So we're trying to go from the 2D orthographic drawings on the left to produce the 3D shape on the right. So we first look at our dimensions. So when we draw the isometric, we have to draw the bounding box, and we first kind of look at the height, which was 4. So we start drawing 4 cubes high. And then we look at the width, which is 5 cubes. So the width is along that direction, and so we draw 5 cubes along. And the depth is 6. So we draw it in the other direction, we go 6, and we complete the bounding box. So we can make the bounding box. So that is our, and now we draw the projected views on each of the planes. And once we start doing that, we can move the lines down accordingly to make sure that they all start looking. So you start to cut away on objects that no longer are there, because solid lines indicate there's a depth or a difference in the plane. And once you are able to do that, you can take away the hidden lines, because the hidden lines are there to show you something happening behind the scenes, and you can erase the final shape and erase the bounding box so that you get the final shape. So this is a complicated one, but it's a good example of how to use the glass box theory. And here's an example of drawing, going from 2D to 3D within the Spatial Viz app. So if we watch the video, you can see we're going to start by drawing the right side view, and it's a four blocks on the first level and then one block. And then we're going to move over and we're going to do the front view. And so that's how we do it. And then we're going to draw the top view, and we're going to recognize that the top has a change in elevation. So that concludes the video on 2D to 3D, so going from orthographic projections to isometrics, and you can start that lesson in the app.